Tonight's lecture is over freshwater resources. The Colorado River is emblematic of the breathtaking beauty of the American Southwest. It even helped carve, over the course of millions of years, the iconic Grand Canyon in Arizona. The Colorado, flowing through a region known as the Colorado River Basin, the area that feeds the Colorado and through which the river flows, also known as its watershed, provides life-sustaining fresh water to some 36 million people, as well as countless animals, plants, and other organisms in Arizona, California, Colorado, New Mexico, Nevada, Utah, and Mexico. Wyoming, too, is part of this river system. Its Green River is the largest tributary that feeds into the Colorado. Over the course of its long life, the Colorado River has had a rich and dramatic history, but today its future is uncertain. The modern saga of the Colorado River, the backstory that explains why its fate is now so precarious, begins in 1922. That's when officials from the 7 U.S. states that lie in the Colorado River Basin signed an agreement that divided its flow between the 4 upper states, which is called the Upper Basin, and the 3 lower states, which is called the Lower Basin. Unfortunately, the agreement did not determine how the water would be divided up between the 3 lower states, and Arizona and California immediately began bickering over their share. The 2 states even briefly went to war over these water rights in 1934. Arguments over the Colorado's water have once again reached a fever pitch, and the cause, yet again, can be traced back to that century-old agreement. Because water flows were unusually high in 1922, officials vastly overestimated the river's annual flow, and the states began using more water than was sustainable. Now, 100 years later, the continued overuse of the Colorado's water, combined with decades-long droughts and the effects of climate change, have put the Southwest in a precarious situation. In 2019, Lake Mead, a reservoir that provides water to Las Vegas and parts of Arizona and California, was only 40% full, with water at 1,088 feet above sea level. If the water drops below 950 feet above sea level, the water will no longer turn the dam's turbines. At 895 feet above sea level, water will stop flowing out at all. Water from the Colorado rarely reaches its outlet at the ocean in the Gulf of California, the narrow body of water that separates the Mexican state of Baja California from the rest of Mexico, and the river's southernmost reaches in Arizona could soon begin to see a similar drawdown and loss of flow. In response, officials from 7 U.S. states signed the Colorado River Basin Drought Contingency Plan in May of 2019. And that brings us to key concept number 1. Only 2.5% of the water on Earth is freshwater, and very little of that is accessible to humans. Fortunately, even this small percentage represents a large amount of water. So water is vital to life on Earth. It connects ecosystems and provides many important ecosystem services that animals and plants require to live. Water is habitat to countless species, and it is the major component of most cells. Up to 75% of the human body consists of water. Our cells must have water for needed chemical reactions. Water also facilitates the transport of nutrients and the regulation of body temperature, just to name a few vital functions. But our bodies need liquid fresh water to survive. Ocean water is too salty for human consumption, and it is toxic in large doses. However, the vast majority of water on Earth is salt water, and that's around 97.5%. Fresh water makes up barely 2.5% of the total, and nearly 70% of that is trapped in glaciers and ice caps at the poles. To meet our needs, we depend on the fresh water trapped underground, which is called groundwater, and in surface waters like lakes, streams, and rivers, that is slightly less than 1% of all the water on Earth. But there is a lot of water on the planet. About 75% of its surface is covered with water, totaling around 370 trillion gallons of water. Even 1% of such a large number is still quite a bit of water. Like many bodies of water, the Colorado is a lifeline for the human communities that depend on it as their primary water source. But that can also lead to water shortages if more is removed than replaced. The Colorado River and its tributaries that empty into it are largely fed by the Rocky Mountain snowmelts. Since the amount of snowfall changes every year, scientists expect to have some years of drought and some years of abundance. And that brings us to infographic number 1. Most of the water on Earth is found in the oceans, and most of the fresh water is tied up in ice and snow. A small fraction of all the Earth's water is suitable for us to use, but with more than 370 trillion gallons of water on the planet, that is still quite a bit of water. And that brings us to key concept number 2. Water moves through the environment via the water cycle, a process that constantly recycles water on Earth through surface and groundwater plants and the atmosphere. So whenever there is water, it is constantly moving through the environment via the water cycle or the hydrologic cycle. Heat from the sun causes water to evaporate from surface waters and land surfaces. At the same time, plant roots pull up water from the soil and then release some into the atmosphere in a process called transpiration. Plants with deep roots, like trees, may bring up thousands of gallons of water a year, releasing much of this to the atmosphere. Altogether, the combination of evaporation and transpiration, evapotranspiration, sends more than 17 trillion gallons of water vapor into the atmosphere every year. Once aloft, that water condenses into clouds, and that's called condensation, and may fall back to the earth as precipitation, which could be rain, snow, sleet, etc. Almost all precipitation ends up falling on the oceans, and a tiny remainder falls on land. This latter portion is the part humans can harvest for their own use. We access fresh water from lakes, rivers, and groundwater. Water from both surface and groundwater sources eventually makes its way back to the oceans. And that brings us to infographic number 2. Water cycles between liquid and gaseous forms as it moves through space and time. Ocean water, which we cannot use, is converted to fresh water when it evaporates and falls back to the earth as precipitation, refilling surface and underground freshwater supplies. Liquid fresh water is a renewable resource as long as we don't use it faster than it is naturally replenished. And that brings us to key concept number 3. Surface waters provide fresh water to human communities, but if we remove water faster than it is replaced, the sources can run dry. Water wars can also erupt. Groundwater supplies can shrink due to over-withdrawal and to decreased infiltration, causing wells to run dry or become contaminated with salt water in coastal regions. So of all the water that we use in the United States, more than 70% comes from surface water sources, though groundwater too is an important source of fresh water in many areas. Surface water can be accessed on a large scale with pumping stations and on a small scale by hand. It can also be diverted via canals and pipes to deliver water to places that need it, such as farms and power plants or even distant cities. Surface water sources can be threatened by problems such as climate change, pollution, and excessive water withdrawal. Over-withdrawal of water is not just a problem for the Colorado River in the arid Southwest, but disputes over water in the Chattahoochee River, which runs through Georgia and Florida, have reached the U.S. Supreme Court. Much of the city of Atlanta, Georgia, relies on the Chattahoochee River for its drinking water, and its population has grown, so has the city's withdrawals from the rivers. Georgia farmers farther south also divert water from the Flint River, which joins the Chattahoochee before both of them drain into the Apalachicola River in the Florida Panhandle. Paired with the regional drought, all this upstream withdrawal means that less water reaches Florida and the coastal regions there that depend on it. Water scarcity threatens not just the people who need water, but also the other organisms and the plants that need it too. In 2012, the once thriving Apalachicola Bay oyster industry, which provides 90% of Florida's oysters, collapsed as oyster numbers plummeted. Although the causes of the sudden shortage were likely multifaceted, in a 2013 report, the Florida Fish and Wildlife Commission highlighted a lack of fresh water flow into the rivers and estuaries as a major culprit. Oysters thrive in regions where fresh water meets the sea, but as freshwater flows diminished, the salinity of the water increased to levels too high for the oysters to tolerate. The collapse intensified an already existing Chattahoochee water war. A water war is a political conflict over the allocation of water resources, similar to the water war ongoing in the southwest of the United States. Groundwater is another significant source of fresh water for the United States. Many people draw their water up from an underground region of permeable soil or porous rock saturated with water called an aquifer. These groundwater sources receive water from rainfall and snowmelt that soaks into the ground through infiltration. Plant roots take up some of the water along the way, but much of the water continues to move downward, filling every available space in the aquifer. As the water trickles down, it becomes naturally filtered by rocks and soil, which trap bacteria and other contaminants as the water passes by. So the top of this water-saturated region, referred to as the water table, rises and falls due to seasonal weather changes or human withdrawals. In addition to withdrawals, anything that reduces infiltration will also decrease the amount of water we could sustainably remove by reducing the rate at which the aquifer refills. Infiltration is hampered in urban and suburban settings because of all the hard surfaces such as roads and buildings. Even a typical suburban lawn is so compacted from our home construction process that very little water infiltrates the ground. Urban and suburban designs that provide ways for water to soak into the ground, such as permeable pavement and rain gardens, can help refill aquifers as well as help prevent flooding even after heavy rainfalls. Over-withdrawing water from aquifers in coastal areas can result in saltwater intrusion. That is the movement of saltwater into aquifer spaces left by missing fresh water. Groundwater levels are typically higher than sea level, so saltwater doesn't infiltrate saturated aquifer regions. But when too much water is being removed, saltwater can seep into empty spaces, potentially rendering an aquifer unusable. To prevent this from happening, some coastal communities pump water into their aquifers. For instance, Orange County, California, gets about half of its water from the Colorado River, treats its sewage water to the point that it can be drinkable, and then pumps it into aquifers to prevent saltwater intrusion. And that brings us to infographic number 3. Groundwater in aquifers is naturally replenished as it soaks into the ground. Humans can access this groundwater through wells, but we can pull out water faster than it is naturally replaced. This can lead to saltwater intrusion in coastal areas or dry wells in inland areas. Surface pollution can also seep into the ground and contaminate groundwater. And in this slide, we see a sinkhole that is swallowing 3 cars during a heavy rainstorm in Chicago, Illinois in 2013. Aquifers can be weakened when they lose water, and then a heavy rain event may add enough weight to collapse the aquifer, opening up a sinkhole. And that brings us to key concept number 4. Agriculture is the biggest user of water, followed by industrial use and then domestic use. Not surprisingly, domestic use goes up as income goes up. Water shortages can be physical, that is a lack of water, or economic, which is the inability to pay for water. So agriculture is by far the sector that uses the most fresh water. To increase yields or grow high-value crops in areas that are naturally too dry for those crops, we add water. Crop irrigation in the United States consumes 80% of our water. It's even higher in some southwestern states. In the countries of South Asia, closer to 90% of total water usage goes to irrigation. And in the United States, irrigation water comes about equally from surface and groundwater sources, depleting both in some areas. The Ogallala Aquifer, which is the largest groundwater system in North America, underlies 8 states in the Great Plains of the American Midwest. This supplies about 30% of all U.S. irrigation water to these Farm Belt states. but withdrawals far exceed recharge rates, which are only replacing about 15% of what is removed. This has lowered the water table an average of 15 feet, a loss of 30% of its historic capacity, with the most drawdown coming since 1960. The southern reaches of the Ogallala Aquifer are most severely impacted. From Kansas to Texas. Wells have run dry in some areas, and drilling deeper won't help. The groundwater there is just gone. Local water supplies and future agricultural productivity depend on this aquifer. Today, steps are being taken to improve irrigation efficiencies and/or reduce the irrigation water needed for a crop. In the Colorado Basin states, the river is the biggest source of water, and an estimated 78% is used for agriculture. The lion's share of that is used by farmers in the Imperial and Yuma valleys of California and Arizona, where it supports the growth of vegetable crops. A smaller proportion is used by farmers farther north, often to grow crops like alfalfa and corn, which are then used to feed cattle. The rest of the withdrawn water flows to homes and businesses. Some is diverted and sent to distant thirsty cities such as San Diego and Los Angeles. Industrial use of water varies from country to country. It is understandably higher in more developed nations than less developed ones. Thermoelectric power plants such as coal or nuclear facilities use large amounts of water for cooling, and in many developed nations, this represents the biggest portion of industrial water use. In the United States, it accounts for around 85% of the industrial sector's use of water. Domestic water use, that is, the use of water in homes and businesses, is the sector that uses the least amount of water, but there are big differences between nations. In general, water use goes up as income levels go up, but some wealthy nations use more water than others. For example, on average, a United States citizen uses more than 4 times what a citizen of Denmark uses, about twice as much as the world average. People don't always live near abundant sources of fresh water, making access a vital issue. Around the world, many areas suffer from water scarcity, that is, not having sufficient access to clean water supplies. In some dry regions, there is simply not enough water to meet the human need. Many arid nations, like those of the Middle East, parts of Africa, and much of Australia, face water shortages as a way of life. The Middle Eastern countries of Bahrain, Qatar, Kuwait, and Saudi Arabia have the lowest per capita water availability in the world, but these oil-rich nations can afford to invest in costly technology to access water, like facilities to remove salt from seawater. In other areas, particularly in sub-Saharan Africa, there may be water, but people do not have the money to purchase it or dig wells to access it. People in these areas may be getting by on just a few gallons of water a day, and that water may not even be safe to use. Ensuring that all people have access to clean water and sanitation is Goal 6 of the United Nations Sustainable Development Goals. That is a goal that the UN points out that affects the successful achievement of every other goal. Currently, more than half of the world's population, that is around 4 billion people, faces physical water scarcity at least part of the year. By 2050, as many as 5.7 billion people could face water shortages. Much of the water that is available in regions where scarcity is a problem is contaminated with fecal material, human or animal waste, often the result of inadequate sanitation. According to the World Health Organization, around 300,000 gallons of raw sewage enter the Ganges River of India every minute. These waters can be contaminated with raw sewage that contains dangerous pathogens, increasing the chance of disease transmission. All told, as many as 4.5 billion people lack access to sufficient sanitation facilities with serious consequences. The United Nations estimated that in 2018, 5.6 times more people died from contaminated drinking water than from flood, drought, earthquakes, epidemics, and conflict combined. Water wars over the Colorado and Chattahoochee rivers take place in developing countries too, and in economically disadvantaged regions, their effects can be devastating. For instance, Syria has always been an arid country, but its most recent drought from 2006 to 2011 has been called the worst since farmers first began tilling the Fertile Crescent many millennia ago. The drought has affected millions of Syrian farmers, causing so many crop failures that more than 1.5 million farmers have migrated from rural lands into cities, trying to find new ways to make a living. This influx led to social unrest and urban unemployment, as is cited as a contributing factor to the ongoing civil war that began in 2011. And that brings us to infographic number 4. Agriculture is by far the biggest water user globally. By 2050, it is projected that we will need 20% to 30% more water. Much of this increased demand will come from industry and domestic use. Moving on, individuals in more developed countries use far more water per person than those in less developed countries. In some areas, individuals must make do with only a few gallons a day. And this slide outlines Goal 6 of the UN's Sustainable Development Goals. That is, to ensure access to water and sanitation for all. And that brings us to key concept number 5. The United States has one of the world's most dependable purification and delivery systems for tap water thanks to the Safe Drinking Water Act. However, thousands of violations occur each year, and infrastructure upgrades are needed to continue providing safe drinking water. So the United States, like other developed countries, has a well-established water purification and delivery system that provides safe drinking water to the vast majority of its residents. Water is first removed from surface or groundwater sources and treated to make it potable, that is, clean enough for consumption. Water treatment involves several steps to remove sediment and other large contaminants, followed by disinfection, usually with chlorine. Fluoride may also be added to help prevent tooth decay. In the United States, public drinking water is protected under the Safe Drinking Water Act. The Environmental Protection Agency administers the act by setting water quality standards and works with state and local governments and other federal agencies to see that those standards are met. For example, the EPA sets standards for the way water is treated and sets limits for the 6 categories of contaminants, that is, microorganisms, which are pathogens such as bacteria and protozoa, disinfectants such as chlorine, byproducts of disinfectants, inorganic chemicals such as arsenic and lead, organic chemicals including benzene and pesticides, and radionuclides, that is, high-energy particles emitted from radioactive materials. The water quality of environmental waters is regulated by the Clean Water Act. Thanks to the Safe Drinking Water Act, tap water in the United States is among the safest in the world. In fact, the purification process is more significant than it is for bottled water, and as a result, water in plastic bottles has sometimes been found to have higher levels of chemicals than tap water does, although it's not clear whether these higher levels pose a health risk. That said, the U.S. system isn't perfect, and municipal water supplies sometimes get contaminated. The most common contaminant is fecal material, which can cause gastrointestinal illnesses. Water polluted with nitrogen fertilizers can also cause serious problems, especially for infants and young children. Long-term exposure to disinfection byproducts can cause kidney and liver damage, while heavy metals such as arsenic and lead can cause serious harm too. Many U.S. water treatment facilities are old or too small to handle the growing local populations, and much of our water infrastructure, like pipes, is also old, leading to water loss or leaks and contamination. So when the city of Flint, Michigan switched to the nearby Flint River as its new drinking water source in 2015, the water was so corrosive that it caused lead to leach out of old pipes. Before long, Flint's drinking water became contaminated with lead at levels that were up to 7 times higher than the EPA safety limits. The EPA estimates that it will cost billions just to fix existing problems with drinking water infrastructure, such as replacing old pipes. In many communities, water and sewage treatment plants need upgrading too. The EPA's 2016 action plan lays out a framework for addressing these and other issues. And that brings us to infographic number 5. In most places, tap water in the United States is very safe thanks to the Safe Drinking Water Act, but there are still thousands of violations each year. Fecal contamination from sewage and livestock facilities is the most common contaminant. The presence of disinfection byproducts can also exceed allowable limits. Nitrate violations are most common in agricultural areas. The presence of toxic heavy metals like arsenic, lead, copper, etc. occurs less frequently, but when it is present, it presents a major health risk, as is the case of lead contamination in Flint, Michigan. And that brings us to key concept number 6. Wastewater can be decontaminated using high-tech methods that use advanced filtration and chemicals, or low-tech methods that mimic the way wetlands purify water. So wastewater is any kind of used or contaminated water produced by industry, agriculture, homes, and businesses. The water that arrives at municipal wastewater treatment facilities contains used water washed down drains and sewage flushed down toilets in many communities. It also contains stormwater delivered to the facility by storm drains that collect runoff from city streets. Rural homes in the United States that are not connected to a wastewater treatment facility, that is, a city sewage system, use septic systems. This is a waterproof, like for instance, concrete-lined pit buried in the yard that receives the wastewater from the home from sinks, bathtubs, and toilets. Solids settle to the bottom of this septic tank where bacteria begin to digest it. The liquids drain out through perforated pipes buried in gravel-lined, shallow ditches just under the surface of the yard. This drain field allows untreated wastewater to soak into the ground where soil organisms digest much of the organic material so that by the time the water reaches the aquifer, it is decontaminated, as long as the water table is not too close to the surface. When it fills up, the septic tank must be pumped out and the contents disposed of as sewage sludge. So municipalities offer a more technologically advanced system for treating sewage wastewater. In a traditional high-tech facility, wastewater treatment includes initial steps that filter the water and then send it to settling tanks where much of the remaining suspended solids sink to the bottom. The water continues onto other tanks where bacteria digest much of the remaining organic matter. Final treatment includes chemical treatment, such as exposure to chlorine to kill some pathogens, or the addition of other chemicals to remove phosphates and other substances that should not be released. Proper treatment is critical. Sewage can carry pathogenic viruses and bacteria. Swimmers and surfers get exposed to these if poorly treated wastewater is discharged into recreational waters. The goal is not to purify wastewater for consumption, but rather make it safe to release into the environment. However, as we will see in the next section, some communities are purifying wastewater to the point that it is potable. So there are also low-tech methods for sewage treatment that are modeled after natural ecosystems. For instance, in Arcata, California, rather than construct a typical wastewater treatment facility to handle sewage that had been contaminating nearby Humboldt Bay, the city repurposed a retired landfill near the coast by converting it to a wetland, an ecosystem that is permanently or seasonally flooded. A slow river meanders through the wetland where organisms there purify it. To them, it is not sewage, it's food. The Arcata facility depends on nature to perform the job of water purification. No toxic chemicals are used. The water discharged into the ocean is very clean, and the health of the bay ecosystem has improved. Similar facilities have been constructed on a smaller scale, providing wastewater treatment for a single building. And that brings us to key concept number 7. Water scarcity can be addressed by storing water, using dams or underground storage, desalinating water, and using new solutions like purified wastewater. These solutions come with trade-offs. So communities work to ensure sufficient water supplies in a variety of ways. In areas where lakes and rivers are an important source of water, many communities invest in dams. A proposed dam in the Colorado River was in fact the cause of the brief 1934 war that broke out between Arizona and California. When California's Metropolitan Water District began construction on a dam called the Parker Dam that was designed to feed the new Colorado Aqueduct and provide drinking water for parts of California, Arizona's governor sent members of the Arizona National Guard to put a stop to it, declaring martial law. The issue was brought before the United States Supreme Court, which ruled in favor of Arizona, upholding the state's right to oppose construction. Eventually, however, the states reached a compromise and the Parker Dam was finished in 1938. Today, the Colorado Aqueduct provides drinking water for much of Southern California. Dams along the Colorado River capture and divert so much water that the river no longer reaches its outlet in the Gulf of California. This harms that aquatic ecosystem and the communities that depended on its fresh water. In recent years, there have been few instances where enough water was released from the river's southernmost dam to allow water to once again flow to the sea. However, this quickly dries up once these pulse flow episodes are over. So the barriers created by dams slow the flow of rivers and create reservoirs, that is, a large body of water that holds fresh water for a variety of uses. Freshwater source, flood control, electricity production, etc. In the United States, reservoirs often become recreation sites and fishing resources. But while reservoirs are a valuable resource, they can lose enormous amounts of water every day through evaporation, particularly in arid areas. Worldwide, reservoirs lose more water to evaporation than is used for industrial and domestic purposes combined. Critics point out that pumping water underground into depleted aquifers, or what is known as managed aquifer recharge, would be a better way to sequester this water for future use. This helps to prevent evaporation. So in coastal areas, salt can be removed from seawater to make drinking water in a process known as desalination. The largest such facilities in the world are in the Middle East, some of which are processing around 200 million gallons of water per day, about 10 times the volume of two of the U.S.'s largest plants located in Tampa Bay, Florida, and El Paso, Texas. In 2015, a $1 billion desalination plant, the largest facility in the United States, came online in Carlsbad, California, and began producing potable water for San Diego. It is expected to meet about 7% of the city's water needs, about 50 million gallons a day. But the briny water that results from the desalination process is toxic and must be dealt with safely. Furthermore, removing salt and other materials from seawater uses large amounts of energy and is very expensive. Still, thousands of desalination plants worldwide operate today to meet some of the water needs of their regions. So, as is the case in Orange County, California, communities in the Colorado River Basin recycle their wastewater, purifying it to the point that it is safe to consume. Las Vegas, dependent on Lake Mead for its water, sends roughly 90 million gallons of highly purified wastewater per day back to the reservoir, replacing much of what it took. The idea of drinking treated wastewater might not sound appealing, but keep in mind that if your community withdraws water from a surface water source to purify for drinking water, it is likely an upstream community has discharged its treated wastewater into that same water body. In other words, most of us are already drinking purified wastewater. Moving on, technologies that address water scarcity, such as desalination, has 3 extra cleansing steps. That is microfiltration, reverse osmosis, and then it is treated with UV light. And that brings us to infographic number 7. Ensuring ample water supplies is vital for society, and we have some high-tech methods to increase our water supply or to make it more predictably available. They all come with trade-offs that must be evaluated to determine if they are suitable for a given location. And that brings us to infographic number 8. Conservation can effectively address scarcity and includes the use of water-saving technologies, behavioral changes that decrease water use, and consumer choices that minimize our water footprint. So while we have many technologies to address water shortages, an easier and cheaper way to maintain water supplies is simply not to waste so much. For example, water-saving irrigation methods limit loss to evaporation and runoff, thus significantly reducing the water that is used by as much as half. This has the added advantages of protecting surface waters and preventing soil salinization, that is, the buildup of salt as water evaporates, a common problem in dry climates. Choosing to plant crops more suited to the environment and water availability will decrease agricultural water use. And many industrial processes are now designed to reuse water rather than discharge it into the environment. The average United States citizen uses about 140 gallons of water per day in their home. This is considered direct use. That is, water used to meet personal needs of cooking, washing, flushing the toilet, and so on. Small individual changes in households can save quite a bit of that water. In a typical home, toilets are the biggest water users, but low-flow models can save a significant amount. Toilets with 2 flush buttons save even more water. They minimize water used to flush liquids, reserving the stronger water flow for solids. New dishwasher models also conserve water compared with older models, so if you have an old dishwasher, consider upgrading. Low-flow shower heads and faucets can make a difference too. Still, we can make an even bigger impact by changing our behaviors. By taking shorter showers, only running the dishwasher or washing machine when it is full, and only letting the water flow when needed. For example, turn off the faucet when you're brushing your teeth. The water savings from these technologies and behavioral changes can add up. Between 1990 and 2008, the city of Los Angeles, which relies on the Colorado River water, added more than 3 million residents, yet it actually decreased its overall water usage by 4%, in part due to drops in everyday household use. So it is also important to remember that our personal use of water is not limited to direct use of water from the tap. Water is also used on our behalf by industry to produce products and energy that we use and consume. This is called indirect use. When the water footprint of the goods we use or consume is added in, the average daily use of water goes up to 1,100 gallons per person in the United States. For example, blue jeans and other cotton clothing items have a particularly large water footprint because cotton, typically grown in arid climates, is a water-thirsty crop. It requires large amounts of irrigation water, and if improperly applied, much of this irrigation water is lost to evaporation. It is also heavily treated with pesticides, which can pollute local water supplies and raise its water footprint. Further processing, making the fabric, dyeing the fabric, etc., also uses water. Choosing clothing made from organically grown cotton, that is, cotton grown in a way that it uses water sustainably, buying used clothing, or buying fewer clothing items will all reduce the impact of cotton. Levi Strauss & Co. is working to source only sustainably produced cotton for its jeans. That is, cotton grown in a manner that improves the livelihoods and working conditions of the farmers and reduces the environmental impact of growing the cotton with changes such as more efficient irrigation and fewer pesticides. Fresh water is a precious but limited resource. It always has been and always will be. Access to fresh water is unevenly distributed across the globe, and limited access leads to conflict. In any given locale facing a water shortage, we need to use strategies and technologies that make the most sense then and there. What works well in one location or at one point in time may not be ideal in others. But water conservation is needed everywhere because by conserving this precious resource, we will make the water we do have go further and reduce the tensions that make water wars a reality. Thankfully, this idea seems to be catching on in the Colorado River Basin. According to the U.S. Geological Service, per capita water use in 7 states served by the Colorado River Basin dropped
between 1985 and 2010, likely due to improved infrastructure, conservation, and the use of more efficient water-using appliances. This will help, but additional reductions may be needed. It was in anticipation of further reduced flows that the 7 states that share the Colorado River came together in 2019 to draft the Colorado River Basin Drought Contingency Plan. This agreement contains provisions that call for voluntary reductions in water withdrawals if water levels in Lake Mead and Lake Powell, the 2 largest reservoirs on the Colorado River, fall below a specified level. This is a short-term plan, a 7-year agreement that goes out to 2026. After that, more aggressive steps may be needed, reigniting tensions between the North Basin, where most of the water enters the river, and the thirsty South Basin that uses most of the water. Mexico is still part of the equation, with hopes that future withdrawal reductions will restore flow all the way to the Gulf of California. Ultimately, the problem is one of more people and less water. Whether the players in this drama will be able to make the changes needed to save the iconic river is still an unfolding story. And that brings us to infographic number 8. Understanding how we use water helps us make water-saving decisions, which may include behavioral changes or the use of water-efficient technologies. Much water usage can be reduced by buying less stuff and, for those things we do buy, choosing products with a lower water footprint. Because water is needed in the thermoelectrical production of electricity, energy conservation or use of sustainable energy sources will also reduce our water footprint. And in this slide, we see the gallons of water needed to produce 1 pound of food. And in this slide, we see the gallons of water per product. And in this slide, we see our water usage can be reduced by using new water-efficient technologies and by making behavioral changes that don't waste water. And I'll let you go through this table on your own time. And that brings us to our core message for this chapter. Fresh water is a limited essential resource. Water is unevenly distributed on the planet. Water consumption is unequal, and the wise use of water is key to sustainability. And we'll summarize the chapter. It is important to remember that fresh water is a precious but limited resource. Access to fresh water is unevenly distributed across the globe, and limited access can lead to conflict. Dams, reservoirs, and desalination are all methods used to increase the availability of fresh water. But newer promising methods, like those used in Orange County, California, are now available to recover and purify dirty water. But the best way to preserve water is for everyone to use less.